So there are three different Pythagorean identities that we're going to learn about. So sometimes we need to use these identities to help solve and simplify equations and expressions that involve reciprocal functions. We're going to go through and prove the first and second, but it's a good idea to try and glue these again into your memory. They are often found in the formula sheet as well, though, in tests and exams. So the main two are as follows. Sine squared theta plus cos squared theta equals 1. And 1 plus tan squared theta equals sec squared theta. We're going to prove both of these identities. To prove the first identity, we're going to review a little bit about the unit circle. So draw down a unit circle. Looking something like this. So the radius is 1, so it hits my axis as 1, 0, 0, 1, minus 1, 0, and 0, minus 1. Then I'm just going to draw in a line, so the radius, with the angle from the positive x-axis all the way around to that line. That radius line is 1. I also will call the x length here just x, and then the height y. And now I've formed a right angled triangle. So we know that sine theta in our unit circle is opposite over hypotenuse, so y over 1 or just y. We also know that cos theta, that is adjacent over hypotenuse, is x over 1 or just x. Now, because I've drawn in a right angled triangle, I also can use Pythagoras' theorem. So by Pythagoras' theorem, x squared plus y squared equals 1 squared. And now I can just sub in that sine theta equals y and cos theta equals x into this Pythagoras equation. In this way, x squared, well, that will just be cos squared because x is cos theta. And y squared, well, that will just be sine theta squared equals 1. So there is my proof that sine squared theta plus cos squared theta equals 1. Now we have to prove the second theorem, that 1 plus tan squared theta equals sec squared theta. So just by the definition of tan, because I want to tan theta in this equation, I'm going to recall that tan theta equals sine theta over cos theta. Then, from my first equation, I'm going to divide everything by cos squared theta. The reason I'm doing this is to hopefully get sine squared theta over cos squared theta at some point in this equation, so I can have a 1 plus tan squared theta. So we have sine squared theta over cos squared theta plus cos squared theta over cos squared theta equals 1 over cos squared theta just by dividing through. Recall that sine squared theta over cos squared theta is tan squared theta. Cos squared over cos squared, that's just going to be 1. And on the right-hand side, I'm left with 1 over cos squared theta. Remember that 1 over cos theta is sec theta. So 1 over cos squared theta, well, that's the same as sec squared theta. Therefore, I can rewrite this equation as tan squared theta plus 1 is equal to sec squared theta. And that is the proof for the second Pythagorean identity. Equations. So we have if cosec theta is equal to 7 over 4, then we have to find cos theta where theta is between 0 and pi on 2. Your first step is to write cosec theta in terms of its reciprocal. So is it 1 over sine, 1 over cos, or 1 over tan? Hopefully you recall that cosec goes with sine. So I can say that cosec theta is equal to 1 over sine theta. And we know that cosec theta equals 7 over 4. That means 1 over sine theta will also equal 7 over 4. I'm going to leave that there for now. Notice that the next step is that we have to find cos theta. So what we do here is we figure out which Pythagorean identity to use. And we use the Pythagorean identity that has cos theta in it because that's what we're trying to find. So the only Pythagorean identity I know with cos in it is the one that says sine squared theta plus cos squared theta equals 1. Our next step is to make sure that we have sine theta and an expression for sine theta using our step 1. So if 1 over sine theta equals 7 over 4, if I flip both sides, I'm going to get that sine theta equals 4 over 7. So lastly, we have to substitute our sine theta equals 4 over 7 into our Pythagorean identity sine squared theta plus cos squared theta equals 1. Let's do that. If sine theta equals 4 over 7, then sine squared theta would be 4 over 7 squared. I'm not sure what cos squared theta is, so I just leave that as it is. And we have the 1 on the right-hand side. Now rearrange for cos squared theta. Move all the other numbers to the other side. And I'll get that cos squared theta is equal to 33 over 49. We are looking for cos theta, not cos squared theta. So we've got to take the square root of the right-hand side and recall that this could be positive or negative. So if I change the denominator, that could just be written as the square root of 33 over 7. But we need to check the domain to figure out if cos theta is positive or negative. Remember, if theta is between 0 and pi on 2, then cos theta is just in the first quadrant. If it's in the first quadrant, it can only be positive. So my cos theta has to equal positive square root 33 over 7. Last example, using the Pythagoras identities, solve sine theta equals 3 over 5 and theta is between pi on 2 and pi, then we need to find cos and cot of theta. If we're finding cos theta, again, we need to use the identity with cos squared theta in it. So we're going to use that sine squared theta plus cos squared theta equals 1. I know that sine theta is 3 over 5, so let's sub that into our first Pythagorean identity. We'll have 3 over 5 squared plus cos squared theta equals 1. And let's move the numbers to the right-hand side. So we'll get cos squared theta equals 1 minus 3 squared is 9, 5 squared is 25. So I'll end up with cos squared theta equals 16 over 25. Okay, then we take the square root to get cos theta. That's what we're trying to find. Remember, you can take the positive and negative square root. So we have positive, negative, the square root of 16 over 25, which is just positive or negative 4 over 5. Now we have to take into account the specific domain. So recall that my value of theta is between 90 and 180 degrees, or pi on 2 and pi radians. That means that cos theta is in the second quadrant. This is the quadrant where only sine is positive and cos is negative. Therefore, my only solution is the negative 4 over 5. So finally, our answer for cos theta is just negative 4 on 5. And notice that this is less than 1 and greater than minus 1, so we know we're doing something right. To find cot theta, I'm going to use a little bit of knowledge about tan. So tan theta is simply sine theta over cos theta. That means cot theta is equal to 1 over sine theta over cos theta, being its reciprocal. Or if we flip it on its head, we'll have cot theta is equal to cos theta over sine theta. Now, I have a value for cos. I also have a value for sine. Cos was minus 4 over 5, so I can put that on the numerator. And sine was positive 3/5, so I can put that on the denominator, and hopefully something will cancel out. See here that the 5's will cancel out as they're both on the denominators of their individual fractions. So we'll end up with cot theta equals minus 4 over 3. And this is okay because remember it's in the second quadrant and tan is negative in the second quadrant. So cot is also likely to be negative here. It is okay that cot theta is smaller than minus 1 because tan can also be smaller than negative 1. Remember, its range is bigger. That is our answer for cot theta equals minus 4 on 3. I hope you have a wonderful day. So keep working on 14C and attempt the Pythagorean identity part. And we'll do 14D next in class together.